Hi, I'm Chris Steenerson. I'm a community member at lightingbot. In this video, I'm going to walk through how I set up an HDRI sky and create a test scene with physically accurate exposure settings in Unreal Engine. Hopefully it will be a good thing to have a white box level that you can start projects from and already have lighting set up. And you can easily switch your lighting scenarios and switch content in and out. It's just really handy to have as a place to start working on a project. So let's get to that. So in case you don't know about HDRI images, they are basically created from multiple exposures of the same subject so that you can get lighting information that's in areas of the image that normally wouldn't be exposed in a typical image. So you get really bright image information and really like lower, stuff that would be in the shadows that you might not see. And it all gets compiled together in one image with a whole lot of image data in it. So we can use that inside an engine to get really nice, realistic quality lighting, image-based lighting for our environment. It's a nice, quick, easy, and pretty realistic looking way to get things set up. There's a little calibration involved, which is kind of the technical aspect of this that I'm going to walk through, but it's not too hard to do. So, okay, the first thing we need to do is launch Unreal Engine and create a new project. So here we go. I'm in 554. Okay, let's go to the game section and a new blank project. And let's just name this Lighting WB for white box. And let's create that. I'm just going to use a blueprint project. All right, that'll bring us to a blank scene, which we will probably not be using at all. So I'm going to go into the content folder, and I'm going to make a new folder. Just call that levels, and this is where we'll store any like level content that is not lighting, like level geometry and the like. So let's go to right click, go to level to create a new level, and let's call it white box scene, and that will just be our basic level. And I'm going to go ahead and double click that to actually open that. And we don't really, let's save that. Okay, so here we are, our dark scene. Okay, next thing we want to do is go back to the root of the content folder and create another new folder. And we're going to call this one lighting, and this is where we're going to put any lighting assets that we make. Okay, and we're going to go to the levels window. You can get there from Windows Levels here, and I'm just going to go to the tab for that and click the levels drop down, and I'm going to go to create new, and this is going to create another new level, and we'll just call this this is going to be an empty for reals empty level, and this is where we'll put our lights. I'm going to put to lighting, the lighting folder that we made, and then I'm going to make another new folder and call it levels. So this will be for any specific lighting scenarios. I'm just going to call this lighting _day, and we'll save that. And the next thing we want to do is we want to right click the level here, change the streaming method to always loaded. Okay, and once you have your persistent level and your lighting level here, you can double click those to highlight the active, to set the one that you want to be active. I think you can actually do it over here too, but I usually just do it here. So whenever you make new lights or objects, whichever one you have highlighted is going to be the place that it puts that new thing. So it's a little bit of a level of organization you have to kind of be ready to be thinking about as you're making new stuff. Okay, so we're going to go back to the persistent level, and let's just add a cube under little plus shapes cube. And we are in a completely dark scene. See the grid. The other thing that's useful to do is have in your outliner this tab that shows what level you're in. So if you don't have it here, you can just right click any of the tabs and you just check level, and then you'll have that listed here. So you can see where things live after you've made them. So just to demonstrate that, I can switch. If I go to the lighting day, if I wanted this cube to be inside that level, I can right click this. I can say, where is it? Move selected actor to level, and it will put, I'll just go ahead and put the cube in the lighting day level. Now you'll see like it exists in lighting day, and if I hide lighting day, cube disappears. So this is how we're going to set up our lights to be independent from the actual main level that we'll be working in. So I'm going to just switch that back to persistent level. So I have to select my cube and then right click, move selected actors to level. I'm going to go to the lighting level again and just add a directional light just so we can see something. This may not be one we keep, but yeah, now we actually have visibility in our scene. Let's add a plane. Going to the little add to project, shapes, plane. And gonna set that to the default home position and scale it up to 100. I guess it didn't need a Z scale, but anyway. So now we have the ground, and I'll just move this guy up. So we have a scene to be working with. Okay, the next thing we're going to do is we're going to get the sphere that we'll be putting our sky texture on. And to do that, you need to be showing engine content. And to do that, you go to the settings over here in the content browser, and you make sure that show engine content is checked here. And then you will have this engine folder that you can get stuff out of. And I'm going to type editor sphere. And this is a basic sphere that we can just drag in. And I'm going to set this at 0. A couple things we need to do with our sphere so that it doesn't give us problems is to turn off shadow casting. So in your details panel, just search for shadow, and cast shadow should be turned off. And the other thing we need to do is turn off collision, because if you don't and you start your game up, it will shove your character pawn out to the far reaches of the universe. So let's see, where was that one? It's collision presets. You want to turn that to no collision. Okay, so now we have a sphere that won't make anybody angry. Next we want to do is create a folder for our HDRI images that we'll be bringing in. And I'm just going to create a new folder, call it HDRI, High Dynamic Range Images. It's a real ATM machine sort of situation. We want to create our material for this. So we just right click in the empty space and go to material. And we're going to call this M_sky. And this is the master material we'll use for our different skies that we set up. Double click that to open it. And we have our sky material. And what we want to do here is change the shading model to unlit and check two-sided. Okay, this is the point where we will help us to have some actual images to use. And I got these two off of Polyhaven. Drag that one in. Just drag them from your Explorer into your content browser, and it will import those, the correct settings. This one's Golden Gate Hills 2K and Roglin Clear Night 2K. 2K's looks a little fuzzy. You might want to use the 4K if you really want things to look nice and sharp, but just for the purposes of the demo, I'm just going to use the 2K. I'm going to double click this one image and demonstrate here that you get these and their exposure is kind of set somewhere arbitrary. I guess it's trying to choose like the middlemost point of the pixel values it has, and you can change this exposure bias to see that like the really bright areas, if you go down in the exposure, have a lot of detail still in them, like the sun, for instance, which sometimes people will like clone out the sun in an image editing program and then use like a sun that is inside the engine to be able to control it. But for this example today, we're just going to use this with its sun in it already. So yep, we have high dynamic range. Not going to save that change, just going to show that as an example. I'm going to go back into my sky material here and drag in the daytime, the Golden Gate Hills 2K image into the project and go back so that I can see the whole material editor. So we have our image here. We want to take this image and make it so that it's something that we can change out in our material instance. So we're going to change this to a parameter. Right click the node, convert to parameter, and we're going to call this sky texture. That makes sense. Yep, so this will be our sky texture we use. Now we want to make a new just scalar value, so you can do that by holding down the 1 key and clicking in the background. And this we're going to use with a multiply node. Hold down M to click to get a multiply node. And we're going to connect the image to one input of that, and we'll connect this parameter to the other input of that. And this will let us change the brightness, the intensity of the image. And this is going to need to go into emissive color for the sky. How did this get switched back to unlit? I guess I didn't save my settings. So yeah, that's supposed to be unlit. That's why there are all these parameters grayed out, because unlit does not use those. So our sky texture has an error, and it needs the proper UVs to project this thing onto the sphere. By default, it won't land. It won't land right on the object. So what we need to do is there's a node called UV long. What is it called? UV to long lat. UV to longitude latitude. So it basically takes standard UVs and kind of warps them to fit sort of these polar projected textures that these skybox images are using. So the other thing we need to do is get texture coordinates, text coord. So we got to be able to plug in the texture coordinates into the UV to longitude latitude and then into the sky texture. And now we have it. It's very, very dark because we're multiplying by 0 and there's no information there. So we also want to set the default of this. Actually, we want to convert this to a parameter so we can change it in our material instances. So I'm going to convert it to a parameter and call it intensity. And I'm going to set the default value to that to 1 so that it is how the image comes in by default. So now we can see our sky here in our material preview. So that's all we need to do to set up the master material. So I'm going to apply that and then save it and then close it. Now we want to make a material instance out of this material. So I'm going to go and right click the master material and click Create Material Instance, and I'm going to name that MI for Material Instance Sky Day. So this will be our daytime sky, and I'm just going to drag that to the sphere here. And now we've got that going on. So we need to make this sphere bigger, obviously, so that we're looking inside of it. And I'm going to change it to, let's see, I'll just lock this. And actually, I'm going to name this up here first and call it Sky Sphere. And while I'm at it, I'm also going to make sure that it is not in the white box scene. I'm going to put it in the daytime lighting. So I'm going to select that, select lighting day, and move selected actors to level. So it is in the correct level. And I'm going to just leave lighting day active for now. So now we need to scale our sky sphere up. And I'm going to put like 500,000. And that should put it larger than our view. I'm also going to hide this directional light for now. We don't have light still. We need a skylight to actually use our sky sphere for the image-based lighting. So I'm going to go up here and select lights and skylight. The other thing we need to do the material that I forgot in our master material is we need to flag this as being our sky so that the skylight knows that this is what it should be looking to for its lighting information. So just in the details panel in your material, when you have the main material nodes selected, you can just search for sky and check is sky. And then it'll make the rendering look wonky, but it's working. Save that. Okay, and now, where have I gone wrong? Uh-oh, something is wrong. Two-sided was not checked. Whoops, okay, there we go. Two-sided needed to be checked. Again, from when I forgot to save this before. Saving that, now it's happy, now we have a sky. Yeah, okay, so next thing you're going to do is enable real-time capture, and that will make the ground plane look better. Not quite sure what's going on and why it was so brown to begin with, but maybe it was capturing from a different part of the box or something. Okay, so we have our sky in the scene, but our values for exposure don't really make any sense for like in the engine. Like we can see it here, but like our lights setting values to real world physical units aren't going to line up with what this is giving us. So we need to calibrate our sky. So the way we do that is we go to first show in the viewport, and we go to visualize and HDRI or HDRI adaptation. And this will let us see what our exposure is in the viewport. And we want to be able to affect our exposure in the scene so that we can set everything up correctly. So I think the first thing that we can do is make sure our scene exposure is somewhere that makes sense for a daytime scenario. So we'll go ahead and make a post-process volume. Here, volumes, and then post-process volume. And we want to set the extents to that to be infinite. So if you type unbound, actually, there it is, infinite extent unbound, meaning it will affect the whole scene. And then we want to expand the exposure tab. And let's see, auto exposure histogram, we'll turn that on. Let's turn our exposure compensation to 0 so that we're starting from 0. And we'll check min EV and max EV. And we want to change these to what would be normal for a daytime light scenario. So what I'm going to do now is bring up this chart. I've got a couple resources. You can find EV charts all over the place. If you just search for exposure value chart or EV chart, it will give you like this particular one that's on photographylife.com/exposure value. It has what you would have in a particular scenario. So like looking at this, typical subject on a bright cloudy day would be a 13 EV, up to like 16, which is full sunny day, no clouds. So, you know, we want to land somewhere in between 13 and 16. So we'll just, let's go and we'll start from 13 because it seems like a pretty neutral kind of place for a sunny day. Set both of those values to 13, and now it's black because our sky dome, our sky image is not putting out values that match what that should be. So at this point, we want to go into our sky instance, our material instance for our daytime sky, and I'm gonna make it so that this is not covering up the whole viewport. And we're going to go to the global scalar parameter values. And then we have our intensity value we set up, which is that number that's multiplying by to make it brighter. So we can make this bigger and bigger. And we can see on our graph, I wish I don't have a ton of room here, but we're at 13 EV. And most of our values right now in the scene are, you know, really low, between like 2 and 5-ish. So we want to really push this up. I'm going to go ahead and type in like 1,000. And now we've got stuff we can see, but we're still not quite where we should be. So I'll just keep bumping that up to maybe like 1,500 and see where that puts me. Still not quite there. What about 2,500? No, not quite yet. 3,000. Oops, not 300. 3,000. Still not quite. What about 5,000? Okay, we're getting there. We're kind of in the ballpark now. So maybe I'll put it up to like 5,500 just to get a little. Actually, we've overshot the graph here. Let's see. How does it look? Seven. Oh, sorry, the blue value I forgot about. That's just what we're setting. Okay. This isn't too terrible. This feels kind of like sunny day, right? Where your exposure is kind of set, where things aren't blown out or anything at this point. So this feels pretty good. Actually, let's see. What did our chart say specifically for this range? 13. Subject on a bright day, cloudy day. Yeah, so 13 is kind of perfect for what we're trying to do. I understand Unreal is not always in perfect line with what EV values on a real camera would be, but it's pretty close. So, you know, if we're in the ballpark, I think we're doing well. The next thing we want to do is maybe calibrate this a little more finely. We kind of have a general idea that we're in the ballpark now, but what we can also do is find luminance values for things, and we can meter things in our scene with the little light meter for nits here to determine like how bright this pixel actually is, and make sure that it matches up with something in the real world. So what is, you know, I usually meter off of a cloud, like a white cloud, because that's usually something that you can see in an exposure list. So this one I always use, where did it go? Okay. This is a Wikipedia page called Orders of Magnitude Illuminance. And under luminance, there is white illuminated cloud. So that's kind of something we can shoot for. So 10 kilocandelas per meter square that's nits, basically. So 10 nits is going to be, or 10,000 nits is going to be what we want. And so let's see what our clouds are giving us right now. Let's sort of fly around or look around here. We've got that white cloud that's like, it's about 5,000 nits, a little closer to the sun. It's getting up there more, kind of, the sun sort of throws values off since it sort of blows things out sometimes, but so you don't want to be like super duper close when you're trying to meter stuff, but yeah, maybe we could be a little brighter. So like a cloud like this might be a little bit brighter. That was giving us about 8,000. This one's giving us about 6 or 7. So let's go back to our value over here and bump it up even more. What if I do 8,000 intensity? That gets us to 9,000 nits. 8,500. That's about 10. That's close to 10. So what do we got over here? That's a little over 10. So this might be an okay value. So we know like white clouds are as bright as white clouds should be, and the sun blows everything out all over the place. But yeah, that gets us kind of in a little bit more of a specific range. So the next thing we want to do, you can kind of see the values our sky is giving us down here. Now that we're calibrated that way, let's see if I can bring this down a little so we can see better. Save that. I think we're pretty good with our sky. But something about this that still doesn't feel quite right, and it's because we don't actually have a directional light. We're probably getting some directional information from the sun that's in the skybox here, but our actual sun value is, you know, it's not doing a whole heck of a lot because it's, well, turned off right now for one, but also at the default of 10 lux. Like the sun is generally like 100,000 lux. So, I mean, that's a place where we can start. A thing we have to consider though with a skybox that is providing light from a sun in it as well is that we are basically stacking kind of light from two suns together. Even though the one in the skybox isn't really specific enough to do a whole heck of a lot, we have to consider that, like, yeah, this is actually we're kind of getting this light, this simulated sunlight from kind of two sources in the scene. So we might not use 100,000 lux. We might go to something more like 80,000 lux or something like that. And that'll probably get us to something that feels a little closer. It's kind of hard to tell on this white ground. Another thing we can do that can help us out is in the engine content, there is a gray ball material. Do they spell it with an E or a Y? I can't remember. M gray ball. So this is just a material you can slap on stuff. It's an 18% gray, which is a standard people use for albedo and measuring. That's kind of nice and flat. So another thing we can do to check and see that, like, the relationship between our kind of sunlight, direct sunlight value and the light that our sky is giving is we can look at the difference between EV values on two different sides of an object. Usually Actually, before we do that, another thing that we can do is make sure our directional light is actually pointing in the same direction as the sun, because right now it doesn't make any sense. It's the shadow from this box is heading towards the sun, which is not how that works. So I'm gonna hide, just hit G, and oops, that's not gonna work. I'm gonna go to show and hide this light meter for a minute. There we go. And then I want to see my directional light. And this is just kind of a real non-scientific sort of fudgy way to do this, but it works for me. I'm going to scoot the gizmo over. I'm going to get down kind of at eye level on the ground, look at the sun, and make sure this thing is pointing directly at me. So if I'm on the ground and I'm looking straight up at the sun, this thing should be hitting me directly in the eye. So I'm just going to use the rotation values because I can sort of move them and see what's happening. It's a little finicky, but and that's pretty good. That looks like it's hit me right in the eye. So I can back up, and you know, that kind of, well, like I said, it's not scientific. It looks a little off to me, actually. Yeah, maybe it's all right. It might need to go to the side a little or something like this. But anyway, okay, so now we have that set up well enough. And we can see our lit side of the box and our shadow side of the box. And I'm going to turn the eye adaptation back on. Boop. And kind of general rule of thumb is you want the lit side and the shadow side to be about 3 EV apart. So right now our lit side is hitting like just over 14, and then the shadow side is at about 11, so that's pretty close. Maybe our lit side is still a little too bright because of that. I think 3 is the value. But you know, maybe take this down like to, whoops, 75,000. No, our highlights, our hotspot is closer to 14, and our shadow side is right. Still right. I wouldn't have changed much because the directional light's not really doing much. Maybe getting a little bounce from back here, but probably not much. So yeah, that feels like the right ballpark. Got sort of a realistic scene that we can put things into. To take it a step further, let's see here. We'll go ahead and make another lighting scenario here. Let's go to, I say lighting scenario, that is actually an actual proper thing in Unreal Engine, but we're not using those at the moment. They're more for, like if you right click, you can see there's convert to lighting scenario in here somewhere, but that's for baked lighting scenarios. And we're doing this in Lumen right now, you don't really need to set that up, but you might look into the details of that if you are using a baked scene. So let's see. I'm going to go back to my lighting levels and hide this filter where I was typing, and I'm going to duplicate lighting day. Oh, another thing we should have done actually is made a folder called lighting to put our lighting in, because that's just good manners, you know. I'm going to put the post-process volume in there as well. These are all going to be the things that will get loaded and unloaded with our lighting levels in this setup. So that can help. So I'm going to duplicate in the levels. I'm going to duplicate this lighting level and call this lighting night. And what we're going to do now is go into our levels window again. Click levels up here and click add existing. And we can do lighting night. And it'll throw errors at us because it does not like that there are multiple things trying to be the sun and stuff like that. So you can kind of disregard that because you're going to have two on at the same time. You just hide one and show the other. So I'm going to hide day, put night on. We want to do the same thing where we change the streaming method to always loaded here. And in the content browser, we have this set up. This is obviously not night, so what we need to do is make a new material instance for our night sky. So I'm going to go to HDRI here, and we have our master material. I'm just going to right click that again and click create material instance and call this msky or mi sky night. And what we can do is open that up, and where we have the parameter we set up to be able to change the texture, we can click sky texture now, and we can select sky night and then click this little button here to assign that texture. Oh, I think I had the wrong thing selected. Whoops. Yep, I was selecting the material. Select the texture that you're trying to assign to the material instance, and yeah, then click the arrow and it will assign it. Then you can save that, and then we can set an intensity value, and this is going to have like really tiny values in order for this to look like night. So we can do what we did before and look at what an EV value for a nighttime setting might be. In this exposure value document here where it says got nighttime landscape under a full moon is -3, gibbous moon -4, aurora borealis of moderate brightness is -5, and nighttime landscape under a quarter moon. So, you know, our values between -3 and -6, somewhere in that ballpark of EV is gonna give us a nighttime scene. So let me get back here to Unreal. So I'm going to go to post-process volume, and I'm going to scroll down to where we set the min and max EV, and I'm just going to put it at -3. Oops. -3, -3. And it is really blown out right now because the values are really high at the moment. We're still using the sky, the daytime sky. So we have our nighttime sky, and we just need to assign that to our sky sphere. So I'm going to select the material, and I'm going to go here and set this to the night sky. And that will get us, ultimately, where we want to be. But right now it's still kind of messed up, and sometimes when you change lighting in a drastic way, you have to rebuild your reflection captures, at least on the sky. So go to build reflection captures, and that might help us. Not exactly though. Also our directional light is still on. I'm going to turn the directional light off for now, so it is not part of this equation. So now at least we can see something, but this is a night sky and it would not be giving off this much light. So even at 1, this is way too much light. So we need to adjust these values so that it is giving us something that would be closer to what we'd have at night. So maybe 0.5, maybe 0.25, maybe 0.125. And this is where you can see the reflection capture is not updating. Like the lumen scene, I think, is still hanging on to some old information. So I'm going to do 0.05. Getting closer. 0.25. This is kind of like, really like, your eyes have way adjusted to this night sky. I feel like if it's looking this bright still, but 0.0125. Kind of feeling closer. Like some of this is an artistic decision, because like I feel like this image was captured probably with a long exposure, so you know, you've got things that might end up being sort of unrealistically bright, but this feels pretty close. You can see some stars. You know, we got to make some artistic decisions to be able to have something that looks good sometimes, but having those decisions grounded in some reality is always good too, because then you end up with something that looks more realistic and convincing. So I'm going to go to build reflection captures again, and that's, yeah, fix the ground. You know, maybe this is okay. Maybe with this exposure, this sky intensity is what you might have, or what we might want in our game. I would probably be inclined to like bump the exposure up a little more, or take that exposure value down a little more so we see a little more of like the ground. So back to post process. What if we did -4? So we're seeing more sky. You can kind of barely see the ground. I think that's pretty accurate though, because like we can reference our image over here of, you know, the hills and things in this HDR, which you actually may or may not want in a real real scenario. You might just want sky, but this can help us kind of figure out where we are. So just visually looking at the ground that we have, our ground plane compared to this hill, I mean, you know, they're in the ballpark. So this might be okay. I'm gonna turn off. Just gonna hit G and turn off the adaptation. So you could do the same sort of thing with a sunset, you know, lighting scenario, and just have a few different like things you can pull out as needed, which can be a nice thing. Let's see. Finally, the other thing I was gonna do. I was gonna show that you can, you know, we have our nighttime scenario. We can turn that off, flip our daytime scenario on, and it loads up and looks all right. Again, sometimes reflection captures need to be rebuilt, because when you switch from a really bright scenario to a really dark one, it doesn't always update correctly. So, but then we're okay. So yeah, I think that's it. Thank you. I hope this was helpful for folks. And you know, if you have any questions for me, feel free to reach out. I'm in the lightingbot Discord all the time. And I hope to see you there as well. Thanks.